Welcome to the first video of the Python tutorial series. The first tutorial is on the basics and will be split into two videos. In the first video we'll be covering variables, conditions meaning if statements, and more data types such as lists, arrays, and tuples. I'm not going to go too in depth on how to install Python and the IDE which we'll be using Visual Studio Code, but to download Python we're just going to go to python.org/downloads, download the exe, and the only setting we need to change on this is to add Python 3.8 to path, and then we can just click install now, and Python will be installed for you. Then if we come over to Visual Studio Code, all we need to press is download for Windows, and then we can open it up and start adding plugins and change our interpreter to the Python version we just installed. So I'm here in Visual Studio Code, I've just opened it up. And to start using Python, we're going to need to come to this tab here, Extensions. And what you need to do is you can search here for Python, or in my recommended here, we've got the Python plugin here, and we can just press Install to install it on our device. And that will take a second. So once it's installed, let's say uninstall, we need to come up to File. And what we're going to do is open a folder. So I'm just going to open this Python tutorial folder here. We now have it here. What we can do, we can just add a new file, so we'll call it main.py, as this is the main file that we code in. See, we have a Python file here, ready to code. However, this is not going to be the version of Python that we just installed, so what we're going to press is Ctrl-Shift-P to bring up this window here, and then we're going to search for Python interpreter, and then we're going to change it to this version that we just installed, which is 3.8.5. So as you see here, settings file will have came up, which just changes the Python path to the version we're using. So now we're going to get into the first part of programming I'm going to do in this series. So the first thing we're going to look at is how to store and manipulate information in our program. So we do this by using something called variables. So each variable is given a name and a value. For example, we can call it a variable x, and we'll set it equal to 1. So here we have name equals value, and this here, this hashtag, is how we add comments. So this is not actual code, this is just a plain text when you say this is a comment. So in most other programming languages, if you wanted to say x equals 1, we'd have to do int x equals 1. However, in Python we don't need to specify the data types of variables. So say 1, any whole number is an integer, which is why we call it int x, say in C++ or C#. But in this we just leave it as x. Same as for strings, so we can say y equals hello. So in other programming languages it'd be string y equals hello, or even just s. I really cannot type stry equals hello, but we don't need to do that because Python allows us to set variables without specifying the data type. And we can actually just change y to 1 without saying we have necessarily changed the data type. So I've come here to the very professional tool MS Paint to show you a more in-depth look at variables in Python. So say we have, like in the code before, x equals 1. So what the computer does is in RAM, choose this awful text, it gives the variable x a certain address in RAM. So RAM is a memory storage unit in our computer, which is when programs are run to store all the data, and it stores it at certain addresses such as 1, 2, 3, and it goes on. The addresses are normally in hex because it's much more compact. Say x is given the address 1. Let's just change it to 10 so it's easier to understand. So if x is given the address 1, this value 10 will then be stored in the address 1. And then we can then access this value. So if we go to the address 1 and extract the value, it will return 10. So this is a mode of addressing called direct addressing, where we just store the actual data value of the variable in the address. We can also have indirect addressing. Say we have another variable y, equals 9. So we may say that the address of y is in the 2, but you may then say this variable is 3. But in indirect addressing, what the 3 value will do in the 2 address will point to the 3 address, which will store the actual data value of y. So say we want to get the value inside y, we would search in 2, but 2 would return this address 3, so it would then be sent to 3, which would then return 9. So this is just a more secure way of storing data rather than the actual data value being stored in the address. We can use different methods for indirect addressing. It's also one where you can add a certain number. So if we say store y in 2, it will then actually be stored in address 5, because every time we store a value in the address, we add 3 to the address. So if you go back into this code here, we can actually get the address of these variables by using the id command. So this will return id of the address of the y variable, but it's not actually going to output it on the screen. So to output data, we use print. So we can do print id y, and what this will do is print the address of this here, y equals 1. And we can also actually just print y, which will print the actual value of y. So we can press F5 to run our files and debug it as a Python file. Let's take a second to load, and we see here we get the actual data value from this line 7, and we also get the address, which is this long number, normally stored in hex. So we can actually calculate the hex value of this by in here doing hex and in brackets, which will return the hex value of the ID. So you see here, this is the actual address value here, which will be stored in memory. So what we can also do is from the address, we can get the data value. And to do this, we're going to import a module using the import command called ctypes. Now, module is a collection of functions like this, hex, which is not included by default in Python. So another one, for example, is tkinter, which allows you to create GUIs. So to use ctypes, we're going to use the command ctypes dot cast id y, or we can just copy this value here. And we also need to add ctypes dot py object dot value. So this will get the value of the Python object at this address. So we can print this out. Typo there. So this is what happens when you get an error. It actually tells you, as if you went in an ID, it would not. So here we can actually see it prints out the data value of this object. Now if we get rid of dot value here, what we'll actually do is just print out PyObject 1. If we just copy this line, we can do id x, and it will return a different value, which is PyObject 1. Because if we change y equals to 2, and say PyObject 2 and PyObject 1, so that's the actual value. We can also just, if we get rid of this, it will then actually just say hello in here. So this is a bit more advanced than where we're at now, so if you don't understand this, don't worry. So just get rid of all this. The next thing we're going to learn about is more advanced data types than just, say, numbers and strings. So the first one is a list, which you use in Python by using square brackets. So we could say my list equals this. And in here, what we can do, we can store multiple values. So we could say 1 and hello in this one object here. And then to output the values stored in here, we can do print my list, and then we can do square brackets, and then the index of the value we want to print. So lists in Python start at 0. So if we print my list 0, this will print 1. See here it did, and then we can also change it to -1, which would then print hello. I know there's another data type called an array, and actually in Python this has no implementation, but it is essentially just the same as a list, but it can only contain one data type, so we could say 1, 2. This would be an array, as it contains one data type. However, a list contains multiple data types. That's the only difference between a list and an array in Python. So there are other data types that we can use, such as a tuple. So we can define it here in my tuple, and then this time we use normal brackets, and then we can say 1 hello. Now the difference between a list and a tuple is that a list can be changed, so we could do my list1, which will be hello equals hi, and then if we print my list1, should now say hi, because we have changed the value. What if we try to change my tuple 1? What we'll do is come up with an error, because we can't change the value of a tuple. We can print it out like normal, so we can print my tuple 1, which will print hello, but we cannot change the values in this. So this tuples are good if you want a constant list. Now there is one more data type we're going to look at, which is a dictionary. So a dictionary is used with curly brackets, and each item in the dictionary has a key and a value. So we could say greeting as the key, and we do colon hello. So say when we access the greeting member of this dictionary, it will print hello. So we can do print my dictionary square brackets greeting, and what this will do is print out hello. So this is just a way of storing data probably more specifically than just having an index. It allows you to access it easier, because then we could say like age is 24, and then we can print the age. So this gives you a better sense of what this value actually is. Whereas here, if you have 1, you're like, what is that value representing? But here, you know that this 24 here is age. So the final thing we're going to look at in this tutorial is if statements. So we just get rid of all those data here. Well, we're going to look at a conditional statement, an if statement. So we could say if y, and we use double equals hello. So to say if y is hello, which it is here, we could do print hello. So this will just print hello, because that is what y is equal to. But then we change if y is high, print hello. See, nothing will be outputted here because y is not equal to hello. But then we can change this here, double equals. If we change it to an exclamation mark and an equals, it will print hello, because this is saying if y is not equal to high, it'll print hello. But that means you could have y as anything. We just have hi as good morning, and it will still just print hello here. So one thing we can also do with if statements is compare integers. So if we say x is 2, y is 4, and z is 3, we can say if x is more than z, print hello. So this won't print anything, because x, as you can see here, we define as 2, and z is 3, and 3 is more than 2, so this statement is not true. Then we can just change this and say if y is more than z, print hello. And then we can run this, and you can see we'll get hello because 4 is more than 3. So the next thing we can do in Python is actually have more than just one more than or less than or equal to. So we can say if y is more than z is more than x, print hello. So essentially what this is saying, if y is more than z, and y is more than x, and z is more than x, we'll print hello. And in this case, it is, because we have x is 2, z is 3, and y is 4. And if we now change it to y, x, and z, this won't output anything because x is not more than z. So that is a good useful thing in Python that we can use to add operators together to make it easier to code. But say we want to just say compare two of these values, see if they're equal. So we can say if x is equal to 2, which is pretty straightforward, and then we can do and z is equal to 3, print hello. So this will only output hello if x is 2 and z is 3. We can also do or. So if x is 2 or z is 3, so we change z to 4 and run this, we'll still get hello because x equals 2. So some other things we can do with if statements, we could say if x equals 3, print x is 3. But obviously this is not going to run because x is actually 2. So now what we can say is else if, or in Python, elif x is equal to 2. Print x is 2. So we're saying we'll check this condition first. If x is 3, we'll do this. But then if x is not 3, we'll check this condition. If x is 2, we'll print x is 2. So this will print hello, and it'll print x is 2 because x is equal to 2. What if we say x is equal to 4? Now x is neither 3 or 2. We don't know what x is. Well, we do 4, but in this condition we don't. So what we can add is else print x is not 3 or 2. So what else we'll do, if neither of these conditions are met, it will just run the code in here. So this time it will say x is not 3 or 2. So if statements are very useful when we want to compare logic within a code. So for example, we can say y is good morning, and we can say x is 15. So if y is equal to good morning, and what we can actually do in here is have another if statement. If x is equal to 15, print true. We can also have just true, which is another data type, which is a boolean which can have true or false value, which true is equal to 1 and false is equal to 0. So this here will only run if y is equal to good morning and y is equal to 15. This is another way of just saying and x is equal to 15. But rather than what we can actually do here is then add an else. Print y is true. So here, if y is true, we can then check if x is 15. We know they are both true. But if x is not 15, then only y is true. So here, this will print true. If we change the value of x to 13, we'll get y is true because x is not 15, so it will come in here. Check this condition, it will say no, x is not 15, and it will go into this else statement and print this code. So that is the end of the first video of this first tutorial, and we have learned about variables, how they're stored in memory, if statements, and how to nest them in each other, which is an if statement in an if statement, and also more data types. In the second video, we'll be learning about loops, while, and for, and input-output operations. We've already done some output using print, and also string methods, how to manipulate them and using certain different types of strings.